Hi, let's discuss the solution of the given question. Here, what is the given question? The area bounded by the curves y equal to root x, comma 2y minus x plus 3 equal to 0, comma x-axis and line in the first quadrant. Here, our task is to calculate the area between the curves and x-axis which is in the first quadrant. That is our task. Now, let's plot the area and then we will calculate the area. Solution. Here what is the given curve? Y equal to root x. Y equal to root x means, suppose if you apply squaring on both sides, you will get a y square x. It is a parabola symmetric about x axis, then it is easy to draw. So this implies y square equal to x. Next, what is the line? Next one, 2y, not 2x, 2y minus x plus 3 equal to 0. See, directly I am writing in intercept form. So this can be written as x by 3 plus y by minus 3 by 2, which is equals to 1. This is x-intercept, this is y-intercept. Then it is easy to draw this line. So now we plot the region, take y-axis and take x-axis, the curve. This is a curve, y square equals to x, y square equals to x. And next, see, there is a x-intercept means somewhere else 3 and which is located on x-axis. Similarly, minus 3 by t, which is located on the negative side of y-axis. So take one line here like this. Now this is the this one. Let me plot. This point is a, see, x-intercept means 3 comma 0. This point not required. See, something 0 comma minus 3 by 2. So now this region we require. Exactly, let me draw vertical lines. See, this region we require. So you have to calculate the area of this region. So this region between these two curves and axis at the same time which lies in the first quadrant. So here, now here this is a point of intersection. First, in the next step, let's calculate the point of intersection. So then we can decide the limits of the integration. Now what are the given curves here? Y equal to root x and 2y minus x plus root 3. See, from these two you can write. See, what is that? From the given line, 2y equal to minus x minus 3. Already they have given y equal to how much? Root x. 2 root x equals to x minus 3. Squaring on both sides. This implies 4x equal to x square plus 9 minus 6x. The next step, this implies x square minus 4x minus 6x minus 4x equals to minus 10x. Next, plus 9, which is equals to 0. This is a quadratic equation. You can write the factors by applying the splitting the midterm. So directly I am writing here. So x square, direct factors I will write. Here 10x is there. 10x can be written as minus 9x and minus x. So factors are x minus 9 into x minus 1 equal to 0. So this implies x equal to 9 comma 1. So x equal to 9 is the solution which satisfies both the curves. So I am taking the x equals to 9. So now we will calculate the values of y. See here, suppose if you take y equal to root x. So y equals to root x means root 9. Root 9 means plus or minus 3. You can take a plus 3. So the required point x comma y equal to 9 comma 3. So let me plot this point on the region here. Let me identify. Here this is the point. This is the point means here x equals to 9, y equal to 3. So here suppose if you observe this line and let me draw one horizontal line which is parallel to x-axis. See, this is the line. 1 second, let me draw clearly. This is the line. So this is the y equals to 3. Now I want to take the limits along y-axis. Limits along y-axis means the integrand should be in terms of y. So what is the upper curve here? When you are calculating the areas, if you take the bounds along x-axis, this is upper curve, this is lower curve. When you are taking along y-axis, this is upper curve, this is UC, this is lower curve. Now you have to take, let me write the required area equals to, you have to take the area between these two curves, means upper curve minus lower curve, along with integration with limits. So required area equals to, see, along y-axis means x equal, see, this is y equals to 0, y equal to 0 to y equal to 3, 0 to 3, limits are 0 to 3. What is upper curve? As I told you, see, this is the line in the sense, see, 2y equal to minus x minus 3, yeah, somewhere else, yeah, already I told, yeah, not 2y, okay, previously if you take along x-axis, the integrand should be in terms of x, y equal to in terms of x. Here in the case, x in the integrand should be in terms of y. You have to write x equals to some function of y. So here, suppose if you take the given curve, x equals to 2y, x equals to 2y plus 3. This is the upper curve, 2y plus 3 minus here x equals to y square. You have to take x equals to y square with respect to y. We consider the limits along y-axis and at the same time integrand in terms of y. So in the next step, which is equals to, directly I am doing, see, 2 into directly splitting the integration along this integrand. So 2 into integral y square by 2, y square by 2. Limits are how much? 0 to 3. Next plus 3 y into 0 to 3. Next minus integral y square dy means y cube by 3 minus y cube by 3. This is 3, not 9. This is 3. 0 to 3. In the next step, directly 2 gets cancelled. 3 square means 9 only. Next, here lower limit is 0, contribution is nil. Here also 3 into upper limit is 3, while lower limit is 0. 3 minus 0, 3. 3 minus 0, 3. 3 into 3, 9. Plus 9. Here also upper limit minus y cube means 3 cube, 27 by 3 means 9. Lower limit is 0, minus 9. Minus 9, just gets cancelled, which is good. 9 square units. This is the required area between the curves and x-axis which are located in first quadrant. This is the final conclusion. So what is the concept we applied here? Simply we wrote the given curves and then we plot the region, and then most important point, we took the bounds, the limits of the integration along y-axis, and the integrand has written in terms of y. We integrated with respect to y. Finally we got this area. So thanks for watching. All the best.